Ladies and gentlemen, let's quickly move on towards the next set of presentation by Mr. Yogesh Kumar, Superintending Engineer and Nodal Officer, Smart Meter, Uttar Pradesh Power Corporation Limited, UPPCL, Shakti Bhavan, Lucknow, UP, India. Functioning as the government body for the project management activities, system integration activities, execution and troubleshooting activities of 40 lakhs AMI project in UP, India. Presently, 11.47 lakhs meter has been already installed. Ladies and gentlemen, with 21 years of experience in electricity distribution and 13 years in the field of transmission, hydro and thermal generation, let's welcome Mr. Yogesh Kumar. Hello.
Thank you. Thank you, Aayera, and good morning to all participants and delegates and speakers to this session. Today, I am telling about the
So, you're not audible, sir. Mr. Yogesh, sir, you are on mute. And so you're on mute, sir.
Okay.
All right. So I would request you to please turn the camera a little because your face is not clearly visible.
Now is visible?
Much better, sir. Please, let's begin the session. Over to you, sir.
Thank you, Aayera, and good morning to all the participants and delegates to this session. I am sharing my PPT about this today's session. Just a minute. So today, my topic is the unlocking innovation, smart meter as foundation for smart grid and smart cities. So we basically the smart meter is the key component for all the work related to smart meter, exceptionally electricity component. So smart meter is the basic component which is used and giving the basic data for all the purposes for the smart grid and smart cities. Basically, okay. Just a minute, sorry. Yes. So basically, when we talk about the smart meter, a smart meter is the defined as the as per IS 16444-205 clause 3.2.1. Smart meter is the end static watt hour meter, which time of use register, internal connect and disconnect switches with two-way communication capability. Something is getting wrong. With the measurement of flow of forward import and both forward and reverse import and export, store and communication the same along with other parameters defined in this standard. It shall be remote access for collecting data, event programming for selected parameter. Basically, smart meter is the key component for smart grid as well as the smart cities. Because when we talk about the smart grid or smart cities, then we have to collect the basic data. When we talk about the basic data means basic data means the current, voltage, energy consumption, power supply position at the consumer end. These are the these are the basic data which govern the grid or grid of the system, and also the compatibility and the mixing of the power from the thermal, hydro, and non-conventional energy. So this is the basic component which is the used for all these purposes. This is the basic diagram for smart meter. Smart meter has the data action. Basically, A is the metering. That is, metering is the as well as in normal meter, normal electronic meter. And second is the data exchange protocol, which convert the data from meter to the communication module for in standard model system. Other is the load switch, which is the connected used for connect and reconnect of the consumer supply. Other is the communication module. Communication module is used for sending the data in both directions from the smart meter to HES MDM and from HES MDM to the smart meter. So this is the basic structure of the smart meter. Next component is related to this is the basic features of the smart meter. The smart meter having the all these features: net metering. First feature is the measurement of electrical parameter. Other is the bidirectional communication. Next is the connect and disconnect switches. Next is tamper event detection and recording. Means the smart meter is detecting all the events, tamper event, and stored in smart meter storage, and then send it to the HES MDM for analysis purposes. Also, remote firmware upgrade is the feature of the smart meter. That means whenever we require to upgrade the smart meter in the tenure of the 10 to 15 year of the smart meter life, then we can remotely upgrade the firmware of the smart meter. Other is the net metering facility. Net metering facility means the meter must record the import and export energy in their register. So we can use smart meter in the both purposes, for net metering as well as the remote normal metering purposes. This is the second step of the smart city and smart grid. Means when we have the smart meter, then how the smart meter is communicating to the our system. Means the smart meter is installed at the premises of the consumer, and from smart meter data is going through the communication module, communication network, maybe GPRS, RF, and other network, to the utility office, and from utility office data is analyzed and used for multiple purposes, and that data can be seen by the consumer at their home by using their laptop or the smartphones. So next step, this is the diagram which represent all the component of the advanced metering system. Mainly, firstly, smart meter. Smart meter is both-way communication through the communication technology. Communication technology may be GPRS, maybe RF, maybe PLC. So all three of technologies may be used in the hybrid or the individual capacity. This data is going to the HES from a smart meter to through the smart meter to HES through the communication, different type of communication. And from HES, all the data is going to MDM through the middleware integration. Maybe HES is installed on different cloud and MDM on different cloud. So there will be need of integration through the middleware integration. Then the data is stored at MDM, and all data is analyzed. All analytic is done at the MDM, and yet this data is sent to the our existing billing system. So this is the basic diagram of the basic system of the AMI, advanced metering infrastructure system. So basically, you can see that the smart meter is the basic component for all these purposes. Because the basic data is we are receiving from the smart meter, which is analyzed at the MDM, and at the MDM we can analyze the consumption pattern of the consumer as well as the supply connect reconnect position, loading of the distribution transformer, because the smart meter has to be installed also at the distribution transformer. So we have the all data, all analysis, so we can find out the when the consumer is using what type of equipment by using AI, artificial intelligence, and we can learn our system about the how to use the data for multiple purposes. Multiple purposes, it means when we talk about the smart grid or smart city, then there we have the multiple type of component, generation component, and multiple type of load component. So all of the mixing of the component, utility use of component energy in the efficient manner will only be possible by using the data analytic that at the MDM itself. So all the data is received from the smart meter at the MDM will be utilized for smart grid and smart cities purposes. So when we talk about the smart grid is an electrical grid with automation, communication, and IT system, and can monitor power flow from point of generation to point of consumption, even down or appliances level, and control power flow or outflow of load to match generation in real time or near real time. A smart grid can be achieved by implementing efficient transmission and distribution system operation, consumer integration, and renewable and integration. A smart grid solution helps to monitor, measure, and control power flow in real time. That can contribute to identification of losses and thereby appropriate technical and managerial action can be taken to asset the losses. Means when we talk about the smart grid, that the smart grid using by smart grid is by using the data from the smart meter convert and use data for fully automation of the electrical network. This is the basic pictorial graph of the smart grid. Means all the component of the electrical parameters are interconnected by each other through the network, and data transfer is from one system to other system. Like from customer to the all system, next is distribution, generation, generation में bulk generation, non-bulk generation, and different type of generation. There's hydro generation, thermal, wind, and all other type of generation. Then this generation is transmitted to the transmission line. Then the transmission line and market where to purchase the supply, and operations, multiple operations. So all these are things are interconnected through the network from server to server, and data received from the smart meter only is utilized for all these purposes, all this type of calculations. When we talk about the smart grid is the self-healing, made the automatically detect and respond to actual emerging distribution and transmission problem. Means whenever any trouble or any disconnection, smart disconnection, or any failure of the feeder comes, or the exception energy of wind or solar energy is received, then there will be disbalance in the system. At that time, only the data received from the smart meter is available for the analytic purposes, and that data will help us to stabilize all the system to the perfection and highly economical use with the electrical network. Next is the motivate and involve the consumer. Consumer are well informed and involved in the activities of the power system. Means as in where, then on real time basis, when there will be any interruption at the consumer supply DT level, or the transmission level, or the generation level, that will affect the supply of the consumer. So the consumer may be intimated on the real time by using all the smart grid system, so that the consumer is satisfied and may plan their activity accordingly to supply position. Resist attack means the resistance of the attacks from the outside, or the cyber attacks, or multiple type of attack may be restored, or the any failure may be restored by using the data from the smart meter and other meters installed at the different levels. Accommodate all type of generation and storage options. All type of generation like thermal, hydro, wind, solar, etc. may be accommodated in the very efficient manner. It means in daytime there will be excess of the solar energy, and many places, many times wind energy is in excess. So we can economically mix the wind and solar energy and tidal and other type of non-conventional energy to the thermal and hydro energy, so that with the minimum use of thermal and hydro energy, we can utilize non-conventional energy for the so that we can save the thermal and hydro potential for the long time of the system. Similarly, provide quality power means we a quality power means a consumer is informed time that their supply will be interrupted, and consumer will get the very reliable supply, exact voltage at their premises. Other thing is the consumer may be informed in advance that the from this slot to this slot in the day, you will get the supply with the cheaper rate, so that the consumer may be encouraged to use the power when we have the excess power in the system. All this will be possible only when we integrate all the systems of the system as a in the smart grid system. Also, the optimize asset and operate efficiently. So we can optimize all the assets as well as the equipment very efficiently. Means a consumer having multiple type of load in their houses, means the consumer having a solar AC in AC heater, washing machine, dishwasher, and other type of equipment that has to be used by consumer. When we inform the consumer in advance that
Going. Just right.
okay. In advance that the from particular time to particular time he will get the supply in cheaper rate, so consumer will arrange his equipment through the remote or other means, that the when the cheaper supply, then he is using their AC for cooling purposes, so that the his house or room is cool in cheaper hours. And when the power is costlier, then he can minimum use of the AC. And similarly, washing machine and dishwasher. So this will give the both type of benefit. That one type of benefit is the consumer getting the cheaper supply, and he can manage their bills to the lower side. As per utility perspective, utility have to install minimum assets or optimize their asset, because when supply is cheaper, then consumer is using different type of load, and when supply is in peak hour, then he is using a different type of load. So basically, by this optimization of all this using supply by the consumer, we can optimize the assets. Assets meet transformer, distribution lines, transmission lines. We can optimize all these things, and also optimize the mix of the generation and different type of generation. So when the all these things are connected, then we can optimize all the parameters with the minimum use, minimum asset, and very efficiently and cheaper and cost saving also. So all these factors will be utilized by the when we use the smart grid. The basic component of the smart grid, when we talk the smart grid.
So sorry to interrupt. We just have 1 minute left, sir. Just 1 minute left for you, sir. To
Okay.
over, yeah. Thanks.
So smart meter component, these are the components for smart meter. SCADA, GIS, SCADA with supervisory control, GIS, ERP, customer information system, our outage management system, advanced meeting, communication, advanced distribution management, data analytics. So you can see that all these components is using the data that is received from the smart meter. So smart meter having the very important role in the future for smart grid purposes. The feature of the smart grid is the real-time monitoring, automated outage management and faster resolution, dynamic pricing mechanism, incentivize a consumer to alert users during the different time of day based for on pricing signal, better energy management, in-house display, web portal and mobile application, track and manage energy usage, opportunity to reduce the consume electricity. So these are the basic features for smart grid. Benefits for the utility perspective, we talk the reduce the TNC losses, peak load management, improve quality of supply and reliability, reduction in power purchase cost, better asset management, increased grid visibility, self-healing grid, renewable integration and asset of electricity, increased options such as TOU, tariff, DR programs and net metering, satisfies consumer and financial sound utilities. When we all this is connected, then we talk the smart city. These are the component of the smart city. Then you can find that the very assured electricity supply is the very important component for the smart city that we are planning in the future.
So we have to wrap up the session
Okay.
because
Okay,
we have
madam.
panelists waiting. Yeah.
Okay. Thank you from my side. Any question? If
So we are gonna send you the questions on your email by end of the day, sir. Thank you so much.
Okay.
Thank you.
Thank you.